We're changing it up a little bit this week on Whether or Not. We have a few extra friends in the studio bringing you a wide range of nature in the news stories, ranging from the dinosaurs to the world's bravest meteorologists. And we also have a feature by Addis on some very special weather balloons being launched right here at Penn State. All that and more coming up. Whether or Not starts right now. Hello and welcome to this week's edition of Whether or Not. I am your host, Brian Cizek.
And I'm your co-host, Kristy Steward.
Well, Kristy, it's been a chilly last few days, and we had that front move through during the football game, and it brought some rain to the area, but at least it wasn't as cold as it was the week before, where temperatures were in the 20s for the tailgates.
Yeah, that's right. It was a little bit warmer, but we are below average these last few days, temperature-wise, and you know, it really does feel like the end of November finally here.
Yes, you can feel like winter is just around the corner and we can get those heavy coats out, and hopefully we might get some snow this year for those of you that like to hit the slopes and go skiing or snowboarding.
Yeah, hopefully we'll see a little bit of that snowfall coming up in the near future.
Yes, but anyways, we got a very special edition of Whether or Not this week. We have some extra friends in the studio bringing you some extra nature in the news stories. So without further ado, let's head into, well, nature in the news. A new study reveals that the dinosaurs might have survived had the asteroid that killed them hit almost anywhere else on Earth. The 6-mile-wide asteroid struck Mexico's Yucatan Peninsula right near the town of Chicxulub about 66 million years ago. Previous studies suggested that the impact would have shot huge amounts of ash, soot, and dust into the atmosphere, which in turn blocks sunlight from reaching Earth's surface, which would then cause Earth to rapidly cool. This so-called impact winter killed off dinosaurs as well as more than 75% of all other animal species on Earth. In a recently released study, Japanese researchers determined that the location where the asteroid struck had a particularly large amount of hydrocarbon in the rock. Because of this, it produced an extremely large amount of soot. After doing some computer simulations, they concluded that had the asteroid struck 87% of anywhere else on Earth, the dinosaurs would have survived because less soot would have been blasted into the air. So the next time you're having some bad luck, just remember that you probably aren't as unlucky as the dinosaurs were.
It's about that time of year again when we start to see black ice on the roads. Black ice can form a few different ways. One way is when it rains in the atmosphere, but the surface temperature is at or below 32 degrees Fahrenheit. This causes the rain to freeze on impact, creating ice. It can also form with sleet and the refreezing of snow or water. Black ice is most common in areas that are shaded or tree covered, where it's hard for sunlight to reach the ground. It's also commonly found on bridges and overpasses. The prime time for ice formation is between sunset and sunrise, when temperatures are the lowest. You can use your car thermometer as an initial gauge for determining road conditions, but depending on the placement of this thermometer on your car, it might not be reliable. One of the best methods to see if there's black ice is to look at the pavement before you drive. If it's dry but there's shiny spots, there most likely is black ice. If you happen to hit black ice while driving, stay calm, don't brake or overcorrect your steering wheel, and ride it out.
The National Weather Service recently announced that we are officially in a La Nina pattern. As opposed to its more famous big brother El Nino, La Nina describes sea surface temperatures in the tropical Pacific Ocean that are cooler than average. This natural cooling of the ocean water affects weather all over the planet. Typically, during La Nina events, cold and stormy weather bombards the north central and northwestern United States repeatedly during the winter. The southern U.S. tends to end up on the mild and dry side. For those of us here in central Pennsylvania, we tend to be slightly wetter and warmer than average during La Ninas. But La Nina is not the only controller of winter weather. Here in the eastern U.S., the character of the winter is often defined by how frequently strong areas of high pressure develop near Greenland. These are known as blocking patterns and force cold air in Canada to spill southward. These patterns can't be predicted more than a week or two in advance, so don't give up your hopes quite yet for a snowy winter.
The bravest meteorologists in the world belong to SOUT, the Special Operations Weather Team Air Force Unit. These men and women not only have to pass the same physical tests as their fellow servicemen, but they also have to earn the equivalent of an undergraduate meteorology degree in 8 months instead of the usual 4 years. American troops overseas rely heavily on accurate forecasts to gain an upper hand and keep everyone safe. Ultimately, the meteorologist has the final call on whether or not a mission is a go. Something as minimal as knowing when dew will form can make or break a mission. If troops execute a nighttime mission, the dew will erase any footprints left behind. If there's low cloud cover, air assistance won't be available during missions. On humanitarian aid missions, warning villages about avalanches and flooding become a priority. However, being a special ops meteorologist comes with its own challenges. There are times they are fired upon when collecting weather data in the air, and during unfortunate occasions, they have to multitask holding a comrade's wound while seeing if a medical evacuation is possible.
Global carbon emissions are on the rise again in 2017 after 3 years of little to no growth, according to researchers at the University of East Anglia and the Global Carbon Project. The new research reveals that global emissions from all human activities will reach 41 billion tons in 2017, following a projected 2% rise in burning fossil fuels. The return to growth in global emissions in 2017 is largely due to growth in Chinese emissions, projected to grow by 3.5% in 2017 after 2 years with declining emissions. The use of coal, the main fuel source in China, may rise by 3% due to stronger growth in industrial production and lower hydropower generation due to less rainfall. The growth in 2017 emissions is unwelcome news, says Dr. Glenn Peters of the Center for International Climate Research. But it is too early to say whether it is a one-off event on a way to a global peak in emissions or the start of a new period with upward pressure on global emissions growth. The team flags that persistent uncertainties exist in our ability to estimate recent changes in emissions, particularly when there are unexpected changes as in the last few years.
For years, the National Weather Service has researched and developed a new snow squall warning system to alert motorists of brief but strong bands of snow that can often cause deadly accidents on interstates. And now it'll make its much-anticipated debut very soon. Pennsylvania, along with New York State, Vermont, Michigan, and Wyoming, are beta testing this new warning system beginning this winter, and if successful, the NWS will plan to roll out the program later in 2018. Though many think snow squalls occur only along lake shores, these bands of snow can attach to any cold front, so really, no part of Pennsylvania is safe from whiteout conditions. Back on March 4th, 2017, a snow squall caused a 40-car pileup on Interstate 99 here in Center County, as well as a 70-car crash on Interstate 80 in Clinton County. Aaron Taberski, meteorologist with the National Weather Service, warns of the dangers of these snow squalls, saying, quote, "No road is immune, even side roads or hilly areas. Driving in a snow squall is like driving through a cloud."
While lots of fun goes into looking at weather maps and computer models, something we often tend to forget about is the importance of collecting data. For weather, one of the most important ways to take observations is through a weather balloon launch. Normally, these take place at a National Weather Service office. But thanks to a research aircraft that's flying over Pennsylvania this month, students right here at the Walker Building at Penn State got to launch their very own balloon. Dr. Paul Markowski is a professor of meteorology at the Walker Building. With his focus in mesoscale meteorology, it was his responsibility to oversee the balloon launches that took place over the last few weeks.
This semester there's just a short 2-week window during which we have gotten on loan a research aircraft from the National Science Foundation's instrument deployment pool. The airplane's not based out of Penn State, it's down in Lancaster where Millersville University is, but some of our students have gotten a chance to fly on it. The plane has been flying legs up here in central Pennsylvania on some of the mission days, and our primary role here at Penn State has been to launch weather balloons in support of this project. So the airplane gives you really nice horizontal profiles, but if you really want to know the vertical structure much more rapidly than what an airplane would give you, the balloons are really the way to go.
Balloon launching is a crucial part of everyday operations at the National Weather Service. Throughout the country, balloons are launched twice a day, which are then used as part of data assimilation and numerical weather prediction models. While the objective of the launch is very different with this project, it gives meteorology students a new appreciation of the atmosphere.
So this provided a unique opportunity to examine real-time upper air data, and it was really interesting as some of those balloons got up really high.
Students take part in the balloon launch by first obtaining the radiosonde. The radiosonde is the instrument that is attached to the weather balloon, measuring critical atmospheric variables such as temperature, pressure, and relative humidity. After placing the battery in, the balloon is then filled with helium. The radiosonde is then attached to the balloon, making sure the radiosonde connects with the computer software prior to launch. Once a GPS connection is secured, Markowski gives the students the OK, and the balloons are then released. Not long after, the students huddle around Markowski's computer and observe the incoming data. The data is plotted on what is known as a skew-T log P diagram, a vertical plot of temperature and dew point as pressure decreases logarithmically. Data is collected until connection is lost or the balloon pops.
The balloons we're using here are not really designed to go quite as high as the National Weather Service balloons, which are much larger. Our balloons, I'd say on an average day we get them up to 20,000 feet approximately. Sometimes we get them closer to 30,000 feet. The tracking is done with radio communications. There's a little radio transmitter on there, and that sends a signal back to the base, which is just a computer with an antenna, and we can basically track things for 50 to 75 kilometers. Has been pretty doable. Partly depends on what obstructions there are between the balloon and the antenna back here at the home base.
Markowski said he enjoyed students' company in launching the balloons, and more than any atmospheric phenomenon, the students' eagerness to help out is what surprised him most.
Yeah, I think it's been interesting. I mean, it's I guess my biggest surprise is just how excited some students are by launching a balloon. You'd think it was their 5-year-old birthday party and the clown had just shown up with a tank of helium and some latex balloons. There's something about the novelty of inflating your own balloon and attaching some probes to it and launching it. For us, it's kind of fun. We let it fly, and then we can come in and track it for the next hour on a computer, and kind of watching it in 3 dimensions on the computer, say in software like Google Earth. It's kind of cool. It's not something you get to do every day.
November is a perfect time to launch balloons in Pennsylvania, just with how fast the weather changes. Not only do temperatures near the ground fluctuate, but temperatures aloft can also offer clues when it comes to forecasting fall thunderstorms and lake effect snow. For Weather or Not, I'm Juklo.
Well, there you have it. A lot of nature in the news stories this week.
Yeah, I thought the dinosaur one that you did was very interesting.
Oh, thank you. Yes, all that soot going up into the atmosphere cooled it off and caused the dinosaurs to perish. But anyway, speaking of a cool atmosphere, we asked you earlier in the show, what is the highest daily snowfall for a November day in State College? Was it A, 12.5 inches, B, 15.1 inches, C, 18.9 inches, or D, 22.5 inches? If you guess B, you are correct. 15.1 inches of snow fell in State College on November 15th, 1995.
Yeah, this record beats the greatest December day total of 12.5 inches, but falls very short of the record daily snowfall of 26.6 inches, which was set back on March 3rd, 1994.
Wow, I never would have expected that the November snowfall total would be more than the December. Go figure.
Yeah, me either.
Well, anyways, that's all we have for you on this week's edition of Whether or Not. I hope you all had a great Thanksgiving, and we'll see you next week.